In this video, I'm going to talk about Graham's law of effusion, which can be found in section 13.1 of the textbook. So, for a little bit of background, diffusion is the movement of one material through another material. Diffusion rates depend on particle size. So, this means that the lighter the particles are, the faster the diffusion rates are. Diffusion is related to effusion. The definition of effusion is when a gas escapes through a small opening in a container. A real-life application of effusion would be if you were to get a nail stuck in the tire of your car. The gas particles would leak out through the puncture that the nail made, giving you a flat tire. Graham's law of effusion states that the rate of effusion for a gas is inversely proportional to the square root of the molar mass. The effusion rate can be expressed with this formula. This formula also applies to diffusion, and you can use it to compare diffusion rates between two different gases, and it can be expressed with this formula. The first practice problem is found on page 388, and it asks you to calculate the ratio of effusion rates for nitrogen and for neon. So for this problem, we know that rate A over rate B is equal to the square root of the molar mass of B divided by the molar mass of A. The first thing we need to do is find nitrogen's molar mass. If we were to look that up, we would find that it's 14.01 grams per mole. We also know that nitrogen is a diatomic element, so that means that we would have to multiply this value by 2, and that would get us 28.02 grams per mole. The second step is to find the molar mass of neon. And if we were to look that up, it would be 20.18 grams per mole. The last step is to plug it into the formula. So we would do 20.18 divided by 28.02 and find the square root of that value. This gives us a value of 0.8486. The next practice problem is also found on page 388, and it's number 3. It asks, what is the rate of effusion for a gas with a molar mass twice that of a gas that effuses at a rate of 3.6 moles per minute? So we're solving for the first rate, which is rate A. The question states that rate B is 3.6 moles per minute. So using this information, we can assume that A's molar mass equals B's molar mass times 2. So from this, we can further assume that the molar mass of B divided by the molar mass of A is 0.5 or 1/2. The next thing we need to do is manipulate the formula to isolate the value of A. We would do this by multiplying both sides of the formula by rate B. This would give us rate A being equal to rate B times the square root of the molar mass of B divided by the molar mass of A. The next thing we need to do is plug in the values. So we would get rate A equals 3.6 times the square root of 0.5. If we were to put this into our calculator, we'd get 2.5 moles per minute.